so this problem really has a little bit of a trick. Is we just got to really kind of understand how e and natural log are related. So e to the x and natural log are opposites of each other. So natural log of e to whatever that is just equal to whatever that is. Okay, so I can say this, e to the natural log of e to the square is just going to end up being, so e cancels out the ln, and this is just e squared. So now really what I have is x natural log of e squared. Well, natural log and e squared really once again cancel each other out, and this is just going to be 2. So this is going to end up being then this whole thing, this whole mumbo jumbo here, is just going to end up being 2x. So right now I have 2x minus 3 equals negative 3x. And now it's a nice easy problem to solve. Get our x's together, so add 3x. So if I add 3x over here, or just subtract 3x, so I got negative 5x equals negative 3, then x would equal 3/5. And there we go, there's our answer. So not too bad if we understand how e and natural log are really related, that they are simply opposites and they cancel each other out when they are multiplied by each other. Alright, 17, we have to use the properties of e to really get this. So the first thing we're going to do is divide out the 4. So I have natural log of 3x plus 5, and we're going to divide both sides by 4, is going to equal 1/2. Okay, and then we have, this is going to end up being then e, so we're going to do e on both sides, so that way that'll cancel, so I can do e to the natural log and e to the 1/2, and that would then give me 3x plus 5 equals e to the 1/2 power. And I can go ahead and move these things around and say 3x equals e to the 1/2 minus 5. And I can say then x would equal e to the 1/2 minus 5 divided by 3. And since I don't have a calculator for this problem, that would be as far as you can go. Alright, when we're trying to draw inverses of a graph, we just have to remember that the inverse, so let's first take a couple points here. Let's take this point. Let's take this point here. Let's see, I got a point here. I have a point here and a point here. Let's actually, I don't really see any others that are right in the corner of boxes. So let's go ahead and figure out what those are. So here when x, so I can say the first point when x is negative 6, y is at negative 3. And we're just labeling what we have right now. When x is negative 1, y is negative 1. When x is 0, y was 2. When x was 4, y was 3. And when x was 8, y was 4. And now we're just going to flip them. Right? So the inverse means that we are flipping them across. Right? So I'm changing the y to the x and blah, blah, blah. So really all we have to do is just switch x and y, right? So I can just kind of plot these points. So when x is negative 3, y is going to be negative 6. When x is negative 1, y is negative 1. When x is 2, y is 0. When x is 3, y is 4. And when x is 4, y is 8. And so our graph would just look like that. Would be the inverse graph. And there we go. Ain't nothing to it. Alright, for 19, we're just going to, this f prime of x means we're looking for the inverse. So that means we're just switching x and y. So instead of being y equals 2/3 x minus 2, we're going to make that equation be x equals 2/3 y minus 2 and solve for y. So move our 2 over. So I've got x plus 2 equals 2/3 y. And then well, to get rid of the 2/3, I could multiply by the reciprocal. So this would be 3/2 times x plus 2 equals y. So that would be our f prime of x. It would be the same thing as solving for y. So that's what that is. So there's our inverse function. There's the first part. And then we also want to know what is f of f prime of x. So if we basically, this is just simply checking. So our answer should be just x if we actually did our inverse right. So let's see if I put in this in place of x. So 2/3 times 3/2 x plus 2. That is our 2/3 times x, or 2/3 times f prime of x, and then the minus 2 at the end, which would be quick. So 2/3 times 3/2, well, those just cancel out, and I just get x plus 2 minus 2. And then negative 2 minus 2 goes away, and we just get x. And there we go. There's our quick check to verify that we did it right. This should always come out to be just x, as long as we did our inverse correctly. Right, now these are really easy. It's in the calculator section. The only thing you got to be careful of is just make sure that when you're doing this, make sure that you are in the right mode. So make sure that you're in the radian mode for problem number 20 and plug that in the calculator. And then switch back and make sure that you're in the degree mode for 21 and the degree, and then you could also be in the degree mode for so this would be radians because it's in terms of pi. Obviously this is in terms of degrees, and this one just make sure that you're that you're in degrees as well. So there you go. Those should be really simple. You're just plugging these values in. Make sure that when you do this, you are doing 7.1 and then hitting the cube function, and then hit divide by 4, and then do the natural log of all of that answer. And you will always get the right answer when you plug those in your calculator correctly. Alright, here for 24, really all you're doing is just basically plugging this into your calculator and seeing where does that graph look like. And then you could also do the calculation and see where is your x and y intercept. So you could go to the calc function and see, look for your actual x and y intercept. So this should be a really easy problem. If you have questions, I'll be happy to explain that. But it's just plug it into the calculator and then graph what it shows. Same type of thing for 25. Basically just plug this into the calculator, graph what it shows. A couple of things that you should instantly know, since it's x cubed, it's a positive x cubed, and know that it should be up on the right over here. It should be somehow going down on the left, somewhere over here. When x is 0, it's got to be at 0.6. So my y-intercept here has to be around 0.6. So it'd be somewhere in this neighborhood. It'd be my x-intercept, somewhere along there. Could be some kind of turn here somewhere. But that would be just, once again, plug into the calculator and just draw what it shows. 26. Let's see, what information do we know? It says airplane final altitude, so it tells me, basically I'm just looking at the picture here. We want to know what is this x distance. So I got opposite and adjacent. So I could use tangent. So we could say, well, that means a tangent of 15 has to equal 22,000 divided by x. And that just means that x would have to be 22,000 divided by the tangent of 15. And just plug that into the calculator, and there we go. We have our answer. Done. Nothing really hard about that one. And hopefully this did help you guys between the two different sections. Be happy to explain any other problems and go over some other things that you need to. Good luck.